Good afternoon. My name is Ernesto Medina. Today is April 20th, 2020, and I am going to present to you in Euclidean geometry the proof of the converse to the alternate interior angles theorem. Okay, we're going to start off first by stating to you what the alternate interior angles theorem is, so you can see what that is, and we're going to do basically the opposite, which is why it's called the converse. The alternate interior angles theorem states that if you have two lines, call them L and M, that are cut by a transversal, and the alternate interior angles that are formed, we have two pairs of alternate interior angles. This is one pair, they're alternate interior. If these two alternate interior angles, either pair, are congruent, then the lines are parallel. That's the alternate interior angles theorem. What we're going to do is going to be the opposite, which is called the converse. We're going to prove the converse to this theorem. Now, the converse to the alternate interior angles theorem states the following. If you have two parallel lines, call this line L, line M. Now, to designate parallelism, these symbols are put on the lines. This indicates that these two lines are parallel. Now, if you have two parallel lines cut by a transversal T, the converse to the alternate interior angles theorem states that then, if you have two lines cut by a transversal, the angles made by the lines and the transversal, the alternate interior angles, are congruent. Two lines that are parallel, that are cut by a transversal, the two pairs of alternate interior angles are congruent. This is what we're going to prove. So let's begin. Given two parallel lines, L parallel to M, cut by a transversal T, we need to prove the alternate interior angles are congruent. That's what we're going to prove. So we'll begin by adding another line. Okay, let's label this point P. So this is point P right here. Now, let's label these angles. Let's call this angle here 1 and this angle here 2. So we'll say that angle 1 is not congruent to angle 2. Okay. And we're going to add another line intersecting P. We'll call this line N. And we're gonna assume that line N is parallel to line M. Therefore, by the alternate interior angles theorem, the angle formed by N and the transversal, and we'll call this angle 3. Therefore, if this line is parallel to M and parallel to M, then by the alternate interior angles theorem, angle 3 is congruent to angle 1. But we have the Euclidean parallel postulate. Euclidean parallel postulate. The Euclidean parallel postulate states that if you have a line, we have line M, and there's a point P, not on M, there's only one line passing through P that is parallel to M. Therefore, by the uniqueness of the Euclidean parallel postulate, line N cannot be parallel to M. Therefore, angle 1 is congruent to angle 2. And that's your proof. Thank you.